Hello, Algebra 1. Today we're going to be looking at factoring special cases. There's going to be two cases that we're going to be talking about. This first video will be dealing with the first case, which is a difference of squares, which hopefully sounds familiar. This is a case that we dealt with when we were multiplying binomials together. So as a warm-up here, we're going to be multiplying 2x plus 3 and 2x minus 3. I'm going to show you two ways of doing this. The first way was when we created a Punnett square, where I would put 2x plus 3 on top, 2x minus 3 on the side, and then from here we would carefully just multiply it out. 2x and 2x would be 4x squared. Here I would get 6x, here I would get negative 6x, and here I would get negative 9. And then from there, when we combine like terms, I'm going to have 6x and negative 6x, which in the end just becomes 0x. And so in the end, you're just left with 4x squared minus 9. So we learned how to multiply binomials using a Punnett square. But let me show you another way we did this, right? Using the structure of a difference of squares. So the first thing to note though is that you do have a plus here and a minus. And so there are different signs. Another thing you want to note is that the first terms of each binomial that are being multiplied are the same. And then the last term of each binomial is also the same. And so if you remember, we use the structure where a difference of squares means I'm going to have something squared minus something squared, where I would put 2x in the first position because that's my first term in the binomial. I would put 3 in the second position because that's the second term in my binomial. And then if we carefully multiply this out, you'd end up with the same answer. Right? And so the second method is what we're going to be taking advantage of, the structure, when it comes to factoring a difference of squares. So let's go right into our first example. I'm going to show you how to do this in two different ways. The first way of factoring is using the Xbox method. Now before I use the Xbox method, I'm just going to rewrite this as y squared plus 0x minus 25, just to have that three-term structure, right, a trinomial. From there, I'm going to create my Xbox. If you remember, the first box would be my y squared term. The last box here would be my negative 25. And then from there, we would create our x box. The top would be negative 25. Because if you remember, the way we do that is we take the first number and the last number and we multiply them together. Here I put a 1 here because there's no number in the front. So we know there's a 1. 1 times negative 25 is negative 25. The sum would be 0 because that's the coefficient of my middle term. And then from there, we ask ourselves what two number multiplied to negative 25, add up to 0, 5 and negative 5. That tells me I put 5y here and negative 5y here. And then from there, we're going to try to fill out the dimensions of this Punnett square. So what we're going to do is pick any row or column. I'm going to pick the first row here. If I pick the first row and I ask myself what is the greatest common factor of y squared and 5y, it would just be y. Now, if you notice, I could have just chosen the first row instead. And if I ask myself what's the greatest common factor of y squared and negative 5y, I'd still get y. From here, we would carefully fill out the rest of this Punnett square. And so my final answer then would just be y minus 5, y plus 5. And this is one way of factoring using our Xbox method. But what I could have noticed here is that this is a difference of squares. First thing to note is that I can write this as something squared minus something squared. If you notice, a difference of squares will always have to be a binomial, right? Two terms. Y squared is simply y to the power of 2. 25 is 5 to the power of 2. And because I can write it as a difference of squares, I know that when I factor this, I'm going to have something minus something, something plus something. And so if you remember, the first term here will be the first term of each binomial, so y here and y here. And then the second term that's being squared will go in the second position of each binomial. And if you notice, this is the exact same answer as we got here. So what we're going to do is we're going to be taking advantage of the structure when it comes to factoring a difference of squares. So looking at example 2, we'll do this one together as well. If you notice, I can write this as something squared minus something squared. Again, you need to have a minus sign. That's where the name difference comes from in difference of squares. 9y squared is really the quantity of 3y squared. 16 is 4 squared. And so when I factor this out, I know I'm going to get something minus something, something plus something. This 3y here, the first term that's being squared, I know it's going to go in my first position. So I'm going to put 3y here and 3y here. And then I know that this 4 that's being squared will go in my second position. It's the second term of my binomial. And when I multiply this together, that's the same thing as 9y squared minus 16. And so that is another difference of squares. So hopefully you're getting the hang of this structure, right, when it comes to a difference of squares. At this point, when your screen says your turn, you know what you need to do. I want you to pause the video, work at the problem, and when you're ready, press play. So for this one, I hope you notice that this was a difference of squares, right? Because you can write it as something squared minus something squared. 36x squared is 6x squared. Keep in mind, you really square rooting both 36 and x squared. 49, that's just 7 squared. And then from here, when you write down your final answer, it's going to be something minus something, something plus something, where I know that this 6x is going to go in the first position, right? It's the first term of each binomial. And then I know that this 7 that's being squared will be the second term of each binomial. And this is your final answer. Hopefully you're able to get that correct. This is your first case, a difference of squares. Always remember, you want to have a binomial, right? 2 terms. There should be a minus. That's where the difference comes in. And each term, you should be able to write it as something squared.